Hello. In this video, we want to find the critical numbers and decide where f is increasing and decreasing if f of x equals x minus 1 to the 2/3 power, and then we'll graph the function. Notice I didn't actually graph it here, so we'll graph this on the calculator. Okay, so I want to find the critical numbers. So to find the critical numbers, the first thing I need to do is take the derivative of the function. So we need to find f prime of x. And notice that here we're going to have to use the chain rule. Bring the 2/3 down in front. So 2/3 parentheses, just rewrite the parentheses, and then subtract 1 from the exponent. Subtracting 1 from the exponent gives me negative 1/3. And then multiply by the derivative of the inside. And the inside is x minus 1, so the derivative of that is just 1. So technically we don't even really need it. Now, if we have a negative as an exponent, it can go in the denominator as 2 over, and then this 3 is already in the denominator, and then making that x minus 1 to the positive 1/3 power. And the times 1 just kind of goes away. So this is the derivative. Now, here's the thing. When we have a fraction like this, we set the numerator equal to 0 and the denominator also equal to 0. And the reason why is because we want the critical numbers exist wherever the function is equal to 0, as well as when the function or the derivative is undefined. So we need to set the function equal to 0 by setting the numerator equal to 0, but also setting it equal to 0 for the denominator to find where it is undefined. So the numerator, 2 equaling 0, there aren't any solutions to that. That means that it doesn't give us any critical numbers. The denominator, however, we can set equal to 0. So we get 3 times x minus 1 to the 1/3 power equaling 0. And of course, divide by 3 there, so we get x minus 1 to the 1/3 power is equal to 3. Sorry, 0 divided by 3 is 0, not 3. There we go. Excellent. And then, of course, that means that the argument itself, x minus 1, has to be 0. You can see that by cubing both sides, if you will. And then adding 1 to both sides gives me x equals 1. Now, this is important. These are both only going to be, well, over here there isn't anything over here. But this is only a critical number if it's part of the domain of the function. And you can see that by if you take this 1 and plug it into the original function, if it works, in other words, if it gives you a number, then it's part of the domain. In this case, it will, because if you plug in 1, 1 minus 1 is 0, and 0 to the 2/3 power is 0. So this is part of the domain, which means it is, in fact, a critical number. Now, what that does for us is it allows us to break this number line up into 2 separate regions. One to the left of 1 and one to the right of 1. And now we're going to look at the derivatives. Well, first of all, we're going to have test values. We need values to the left of 1, there we go. And to the left of 1, well, 0 is always a good one if we can. And ask yourself, what is the derivative when x is 0? Well, if you plug in 0 here, 0 minus 1 is negative 1. Negative 1 to the 1/3 power is negative 1, and 3 times negative 1 is negative 3, so that's 2 over negative 3, which simplifies to a negative. Good. So this function is decreasing when it's to the left, to the left of 1. Now, I need a number to the right of 1. Well, how about 2? Notice if you plug in 2, 2 minus 1 is 1, 1 to the 1/3 power is 1, 3 times 1 is 3, 2 over 3 is just 2/3, but it's positive, so positive. Excellent. Now the important thing is that this function is decreasing because it's negative to the left of 1, and it's increasing because it's positive to the right of 1 for the first derivative. So as a result, that tells me that this function is increasing on 2 to infinity, and it is decreasing on negative infinity to 1. And there we go. Good deal. And I'm going to go ahead and go to the calculator, and I will show you what this function looks like there. I'll see you there. Okay, so welcome to the calculator. Let's go ahead and graph this. Parentheses, x minus 1, close parentheses, raised to the 2/3 power. Excellent. And then you can just graph this. Now notice that this function is going down and it's going back up, and it happens at 1. Now that's not the standard window, so if I press zoom 6, there you go. So it's going down and then it's going back up. Excellent. Well, there you go. And notice that at 1 is where this change occurs. Yep. Now notice that the derivative is actually undefined here because this is a sharp edge, and as a result of it having a sharp edge, there is no actual derivative. It's the reason why this derivative was undefined at x equals 1, but the function itself is defined. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.